And we are live. Welcome to Haas Demo Day Live. This is our third edition, the August 2020 edition. As always, we appreciate you spending a few minutes of your day with us. We hope you get something good out of it and enjoy what we're doing. I'm going to start like I always start. I'm holding my mask here. Anytime we're not on camera, everybody's masked up, the entire factory, keeping this place going. All right, today's going to be a shorter version than what you're used to. Today we're going to do two things. We're going to look at the ST30 long bed. It's a new model for us. We've had the ST30 for many years. Now we have a long bed version. We've got the Y-axis version of the machine here today, so we've got an ST30L and an ST30LY. Bob and Andrew are going to be talking about that, and then we're going to move to the machine just behind me, and John Nelson and myself are going to be doing something we call the TSC Challenge. TSC for through spindle coolant. So John's got a really cool demo. He's going to show you the difference between not using TSC and using TSC and show you why the option is so valuable. All right, it's enough of me talking. Let's get going here. Andrew and Bob, it's all you.
Cool. Thanks very much, Brian. Thank you everyone for joining us. As Brian was saying, my name is Andrew. I work in the marketing department here at Haas, and this is Bob Singh. He's a product specialist, mostly dealing with turning centers, of course. And as Brian was saying, we're standing in front of the ST30LY, a long bed lathe, in this case the Y-axis version. As Brian was saying, we also make just the L without the Y-axis.
Yep.
So to start us off, I mean, obviously you're going to use a long bed lathe for pretty much one kind of thing. And what is that?
It's longer parts, longer shafts.
That's right, long shafts, long parts. So why don't we get us started by taking a look inside this thing. Now this machine is fitted with double auto doors, as you're seeing demonstrated here. Pretty slick way to get this thing open and closed.
Yeah.
So tell us a little bit about the travels that we have on this. Like, what's different about this machine compared to a regular one?
To the ST30, it's basically double in length on the Z-axis. So we've gone from just over 30 inches to 60 something inches now. So you can get
62 and a half, I think.
Yeah, and you can get long shafts in like this one here.
Right, and you've got, I think we have up to 66 inches of between the chuck and the tailstock.
Yeah, depending on the work holding or the tools that you got in there, you can squeeze in 66 inches.
But you're probably be a little bit under that. Now this shaft is 57 inches long, right?
57 inches long, and it clears, and there's plenty of room still back there.
Yeah, fits it easily, and you can see with these double doors, we've got 60, I think it's, what, 62 inches here?
Exactly, so we had to have the double doors in there just so you can get these long parts in there so quite easily. And you saw the double doors open with the auto door as well.
Right. You know, before I forget, I just want to mention I've got the live stream here on my phone. Marcus is also checking the chat for your guys' questions. If I see something come up here, I'll try to get to it. We have a pretty tight presentation, so hopefully we can get one in here at some point. So essentially, aside from the Z-axis travel, this is basically an ST30, right?
This is a regular ST30. It's got the if I close this door right now, you'll see it's this bit looks just like a regular ST30. It's got the same X-axis travel. It's got the same Y-axis travel as well.
And now that you drag that door over there, you can see that your pendant is pretty much in the same place it would be on an ST30,
yeah, I mean,
right?
I'm working right next to the chuck. I can bring the pendant over. I'm not, because of this double door and it travels with it, I'm not too far away. I can do all my stuff.
Really,
with
a very similar experience.
Correct.
Right.
Yeah.
So if you were just working on this side, you could move the tailstock and the steady rest back, and you've essentially just done a regular ST30.
Yeah, I mean, even if it was over here, you slide your door to this area and you're still working around this area with the pendant right there.
Right,
yeah.
right. Cool. Okay, so as we're saying here, typically, you're the machinist much more than I am, but typically on this kind of machine, you're going to be doing two sorts of work. You're going to be doing very long shafts that are tailstock supported, and you're going to be doing perhaps mid-range shafts that are supported by the steady rest, right?
Yeah, the long shaft, like I said, 62 inches can go in here, so you can machine the whole diameter without any interruption. Or the other way, it could be a shorter shaft, use a steady rest, and you've got long tools that need to get to the front of the face, so you need the extra Z travel to get the boring bar to the front of the face.
Right, and that's really where the steady rest is coming into play,
exactly.
Supporting that shaft that's hanging way out still.
Yep.
Right, okay. So let's talk a little bit about about the steady rest provision as we call it.
Yeah, we provide the base, and it comes with some connections for the hydraulic hoses, which can be controlled with the foot pedal or with an M code, and you can be programmed basically to go open and close.
Right. Okay.
Yeah.
Sorry, keep going.
And it comes with a steady rest mount and the steady rest from any supplier you.
Right. Yeah.
You
So when you buy the provision, you're buying the mounting plate, all of the hydraulics, actuation and stuff, but the steady rest itself is coming from an outside vendor.
Yeah, and the mounting block as well.
Right. So in this case, we're using Atling, but there's a number.
There's several others. There's LNS as well, but yeah, this one's an Atling steady rest.
Okay, cool. This particular one, can you tell us what the variation that it will, in terms of diameter, what will it?
Yeah, it's currently holding something that's 5 1/8. The travel on this one is 20 millimeters to 200 millimeters, so just under an inch to just under 8 inches. It can hold any size between there.
Cool. And it's always, once it's set up, it's always adjusting to the center of whatever diameter part you have in there, right?
Yeah, it's in line with the chuck and the tailstock.
Okay.
So everything stays on center.
Cool. All right, well, let's see. Let's talk, since we're talking about centering, I guess, let's talk a little bit about how we mount that, just for those of the people that might not be, you might think that it's quite difficult, but it really isn't that involved,
We've
right?
got a 2-minute video already online showing you how to put this on, but basically it's just put the 4 bolts in for the mounting block, hand tighten, same with the steady rest, just hand tighten. So the mounting block can move around a little bit, and the steady rest is just resting on the bolts. It's not actually on center yet.
It has some movement vertically,
It's got some slight movement. So as soon as you put a shaft in here that's supported with a tailstock, something sturdy, you can actuate the steady rest to clamp around the part. It will jump to center line.
So you've supported it with the tailstock initially, right?
Yeah, you started it with the tailstock, you've clamped it, it's found its own center, you clamp down the bolts, clamp down the base, and you can check it with an indicator to make sure it's clamping and clamp to make sure it's not shifting.
So you're making sure you've got a couple of indicators, making sure they're not shifting as you clamp it, right?
You might have to repeat the process a few times to get it right on, within a thou, maybe.
Right, so. And then you know that is on center for all the work that comes after that.
Correct, yes.
Right, okay. Cool, well, so let's move on next to talking about, well, we're going to show you kind of a little program that demonstrates something, a kind of a cool time savings. But to start that, one of the things you probably don't want to do is take your big raw blank like this and start spinning it quickly on the supported by steady rest, right?
Exactly. So we've got this blank in here. It's not a good idea to turn the chuck on right now because this bar is raw stock. It could be bent. Also, it's rough on the Audi,
the surface finish is bad.
You might damage your bearing. So if I spin this at 2,000 RPM, this might start shaking. The bearings might get damaged. But it's there, it's on there now, it's locating, it's actuated, it's just basically putting this it's putting the shaft on center line.
Right. So you got this in here, it's lifted this onto
Yes,
center.
yeah.
Now, typically when you're doing long shaft work, you're going to need to put a center hole in the end of the shaft in order to pick it up with your tailstock, right?
Exactly, and I can't turn the chuck. How do I get the center in there? But luckily,
and often shops will do that offline. Like they'll take the shaft, they'll have like a centering head
there's a
apparatus.
There's a whole separate process just to get one center hole.
Quite a pain in the ass, typically.
It's a pain, yes.
So let's look at how we do that a little bit easier with this Y-axis lathe and live tooling.
Like I said, so we did steady rest it. The material is kind of like on center. That didn't come out right, but
which button? Okay, so talk us through what you're going to do here.
Okay, we're just going to start the machine.
I think we don't have any lights on in there. Maybe we have to turn those on. There we go.
The Y-axis, we're using the live tooling. It's on center. Part's not spinning. We're punching a hole in the front of the part, so the tailstock can support the rest of the part. So
right.
Now, as soon as that's done, we can bring the tailstock in.
Right, so now you've got a hole to support the part.
Yep, tailstock's on there. In a few seconds, the steady rest will retract. And we're ready to do some machining on the OD now. So it was that quick, rather than doing that whole process of centering.
I don't know how long that would take, but it's definitely not that quick by any means.
And then the next thing we're going to do is we're going to come across and skim the diameter where the steady rest actually locates. That'll true up the diameter, it'll clean it up so the bearings can run on a nice smooth surface.
Right. So now you have a place to position the steady rest without a bunch of banging around and run out.
Yeah. So we can actually close this in and do some work on the face, or we can just do some work on the OD with the tailstock in there.
Right. And it's nice that you can see, if you want to bring X down a little bit, you can see that we've got a good amount of clearance here surrounding the steady rest. You're not really restricted in using your tools there.
Yeah, you can see the tools next to the turning tool, they're not interfering with the steady rest. If I clamp or unclamp, everything's clear. So you're not losing any tool stations just because you got a steady rest.
Right. Cool. Okay, so speaking of clearance, we've got there's another aspect of this machine which is different than the regular ST30.
Yeah.
And that's another big amount of clearance that it has down here on this side. So let's take a look at that.
Okay, so I'm just going to move this on towards the chuck as if we're working near the chuck. I'll bring that right in. Now, as you can see, I've got a 20-inch boring bar there, and it's clearing because we've got a Z pocket.
Yeah, the Z extended clearance. I can't remember exactly what it's called.
And it's there's 30 inches of clearance from the turret to the back of that pocket, so you can put in 30-inch long bars.
Right. So you might be, as we're actually going to show in a few minutes here, you might be working on an intermediate length shaft.
Yeah.
And have that long boring bar back here. But then when you come in to finish that work, you still need to be able to get to the end of this OD work.
Exactly. And there's enough stations there. 4 stations will clear that pocket, so you can put at least 2 long boring bars in there, or 2 long drills, whichever tools you need.
That's great. Yeah. Cool. Okay, so as we were just saying, we're going to come back and look at this station again towards the end of our program to look at a shorter shaft that's steady rest supported, kind of a situation more typical of steady rest. But for now, we want to throw it over to John and Brian, who are over on this VF2 SSYT, and they're going to talk about tools and TSC.
All right. Thanks, Andrew. Appreciate it. So, as I said at the beginning, we're going to do something that we're calling the TSC Challenge, Through Spindle Coolant Challenge. You guys all know Mr. John Nelson, Senior Applications Engineer. You've seen him in a ton of videos and all the live streams. So John, one of the things that stuck with me is when we were practicing for this throughout the last couple of days, one of the things you told me that stuck with me is you would never buy a mill without 3 things, 3 options. Programmable coolant, P-Cool, a probe, and then the third one is through spindle coolant.
Yes.
And we have so many options to choose from that it made sense that we're going to show this to everybody and explain why you need through spindle coolant. So John's got a cool demo. It's actually only 42 seconds long. So before we start it, we're going to explain why we're doing this demo and what we're going to show. But before we even get to that, I want to talk about the tools that you're using, because you chose a tool for the demo from HaasTooling.com.
Yeah, absolutely. So all of the drills that we have available on HaasTooling.com right now are all 5 times diameter length, meaning that you can drill 5 times that drill's diameter deep. We make these drills, we offer these drills, sorry, in 2 styles, right? So one style is for steels and cast iron. The other style is designed for stainless steel, high temperature alloys, and also aluminum, and that's the drill that we're going to be showing in the demo today. We have the drills that are designed for steel and cast iron. You can get them in non-TSE versions or TSE versions with holes through the drill. But the styles that we are specialized for stainless steels and high temperature alloys only come with TSE holes, because you really have to have through spindle coolant to deliver coolant right at the cutting edge on those materials, because they work harden so easily.
Right.
One other thing is that we go down to 3/16 of an inch, or 0.188 diameter. It's the smallest drill that we offer with through spindle coolant holes, and I just have to remember which one is the right one to pick up and show everybody. But this is the smallest one that we offer with coolant holes. Now you can get smaller drills with holes through. We just don't offer them because they are such a specialized low volume item that isn't really worth it for us to carry those.
Right. And then also there's some options for coatings on the drills.
Yeah, so all of the drills that are on our website today are a Talon, TIALN, which is titanium nitride aluminum coating, and it's widely recognized as the best coating for high temperature applications, which makes them very good for all purpose, because you can use them on high temperature alloys as well as aluminum.
Right. So we've done some other videos on Haas Tooling, and we got a couple of comments, people questioning the use of that particular coating on aluminum.
Yes. Now, the manufacturer of these drills says you can use them on aluminum with this coating. I've been using them on aluminum with this coating and haven't had a problem at all.
Right.
There are, the wisdom in the industry is that if you're drilling aluminum or machining aluminum, that an uncoated tool is the best, and that probably is the thing, but you shouldn't let Talon coating on a drill prevent you from using that drill.
Right.
Certainly
you're
not going to.
You're going to show everybody that it works more than just fine.
Absolutely. And okay.
So HaasTooling.com. Also, when we were practicing for this, I asked John, you got all the specs right off HaasTooling.com, and that's what you're running, right? And your answer to me was?
Well, not exactly.
Yeah.
So the speed and feed information that we include with the tools on HaasTooling.com is a baseline. It's a starting point for you. If you run the tool in that material at that speed and feed, it's going to cut fine for you. Right. But we obviously recommend that you optimize for your application depending on what it is. You'll start at that baseline and either bring the surface footage up or down. It kind of depends on what you want to do with tool life versus cycle time. Obviously, the faster or harder you push something, it's not going to last quite as long. So you have to find out what's right for you.
That's always the trade-off, right? Cycle time versus tool life.
But in this case, and in cutting aluminum in general, I go as fast as I possibly can. So this machine is a 10,000 RPM spindle, so I'm running a 10,000 RPM drill in these holes. These are 3/8 diameter holes, 5 times depth, so that's 1 inch 875 as far as the depth. And I'm going 180 inches a minute, which turns out to be 18 thousandths per revolution.
Got it.
Now that's pretty high, but with through spindle coolant forcing the chips up out of the hole, it's nothing for these drills. It's going to take it beautifully.
I noticed that Andrew is over here. He has a question
So we have
from
a
the
question
chat.
come in. The question is, can I get TSC field installed?
That's a good question. The answer is yes. So There's a couple different ways. You can get a Haas mill without TSC at all. You can also get a Haas machine, what we call TSC ready, and what that means is that the hoses are all pre-plumbed and in the machine and up through the spindle head. That's lesser cost than TSC, so let's say you're not sure, or maybe you want to wait 3 or 4 months before you can buy the through spindle coolant, that's an option. But any Haas machine can have TSC field installed at any time.
Yeah.
Okay.
Absolutely.
I guess let's show the demo. That's why we're here. Probably tired of us talking. So explain what you're doing here.
All right, so I'm going to go ahead and hit cycle start.
Sally,
and the first thing we're going to do is position over the hole and drill with our high-speed steel drill. But we are going to spot drill this first. With high-speed steel drills, you have to put a spot drill in there if you want that hole to be on location. So we're peck drilling because this is a very flexible drill. If you want that hole to be straight, you've got to peck drill it.
And we are not using through spindle coolant there.
Correct. Not using flood coolant only. Another reason that we need to peck, we got to get that drill out, more coolant down in the hole to continue drilling.
Okay.
So the cycle time to drill that hole was 21 seconds. We wrap it in position, change the tool. I had to do an extra tool change for the spot drill, but the whole process took us 21 seconds. Now let's see what we can do with a through spindle coolant drill. And you can see the coolant coming out of the end of the drill that allows us to really push that drill hard. And there we go. So if I look back here at my timer, I'm at 42 seconds. The first half of this demo took 21 seconds to drill one hole, and then we took another 21 seconds to drill 7 more with through spindle coolant. We really went 7 times faster, or we drilled 7 times more holes in the same amount of time.
Pretty dramatic difference.
Yeah,
obviously.
So Frank, if you wanted to put slide 1 up there, we can show the folks that. Thank you, appreciate that. We can show them our time, our number of holes, and what we really did. If we take that cycle time benefit and move it to a real world example of making a part, we have a part that's 2 minutes and 25 seconds total cycle time. Of that time, 1 minute is drilling holes. When we switch over to through spindle coolant, we can take that 1 minute drilling time and reduce it by 7 times, which gives us 9 seconds. So in other words, for the work that we did in 1 minute, we can now do in 9 seconds. So the other 1 minute, 25 seconds of our operation ends up becoming 1 minute, 34 seconds of total cycle time.
With through spindle coolant.
With through spindle coolant. So we ended up reducing the cycle time by 51 seconds or 35%. Now, if you ran this job for 8 hours a day, not an 8-hour shift, I mean the machine making parts for 8 hours, right? You're going to end up saving $168 in your shop rate at $60 an hour shop rate.
Conservative.
You're going to, very conservative. You're going to end up saving $168 a day. The fantastic savings just by using carbide through spindle coolant drills and taking advantage of the through spindle coolant option that may already be installed on your machine.
Yep. Great. That's a great demo.
Yeah.
Did we go through all the slides?
No. So that was, I should have prompted Frank to show slide 2. Frank, if you put up slide 3, we do get people asking about tooling costs.
We're doing odds. We're skipping the evens.
Yeah. People ask about tooling costs.
I was just going to bring that up.
This carbide TSC drill costs a lot more than that high-speed steel drill. As a matter of fact, it's almost exactly 10 times the price. The 3/8 diameter TSC drill that I use in this demo is $66.95 on our website. And the same drill that I'm using, the high-speed steel drill on MSC Direct or whatever it is, ends up costing about $650. So it's right around 10 times the price. We can do for sure at least 10 times as many holes before that drill becomes dull and needs to be resharpened.
So tooling cost then becomes a wash.
Yeah, you're going to gain, but for our purposes here, let's just say that the tooling cost is even. But then you say, well, I had to pay for that through spindle coolant option. Hey Frank, can you put up number 4, please? The through spindle coolant option on Haas machines is $6,795.
Right.
Remember, we're going to save, in running the machine for 8 hours, we're going to save $168 every day we run that machine. So if I divide that into $67.95, it ends up being about 41 days.
To pay back your investment.
To pay back my investment of through spindle coolant. Now, that's about 2 months worth of work days. Let's say it's 3 months worth of work days. Doesn't matter. After that 3 months, every hole you drill, you're saving money. That's profit going right in your pocket. You paid for the tool, you paid for the option.
Yep.
Now it's pure profit.
Which
That's
is why you told me.
I would never buy a Haas mill without through spindle coolant.
Great explanation. Okay, I think because that demo is so short, can you run it one more time?
Absolutely.
Sal, let's make sure Sal's in tight on that. You ready to go, Sal? All right, let's do it. So again, we start with the center drill.
Start with the center drill.
With a high-speed steel or a cobalt drill, you have to center drill it.
Yeah. And then peck drill with the high speed.
No through spindle coolant here.
Again,
just flood coolant.
1-inch 875 deep.
Yep.
And again, my cycle time, 21 seconds.
21 seconds.
I hit it again. Now we get our carbide TSC drill in there and pound out 7 more in that same amount of time.
I love watching this demo. You've done this for me about 10 times in the last couple of days. I still like watching it. So impressive. And there you have it. 42 seconds, so 21 seconds for 7 holes.
Yeah.
That's really impressive. Cool. Well, thanks, John. I appreciate it. Super cool demo. We're going to go back over to Andrew and Bob. They've got a different part in the machine. Andrew, it's all you.
Thanks, Brian. All right, here we are back at the SD30 LY, and man, I'm going to actuate one of these days. That's for sure. If you put me out here long enough, I'm going to take all the parts out accidentally. So just wanted to say a shout out to everyone that's online. Thank you so much. Looks like we're up to about 180 people online right now. Fantastic. Thank you for joining us. Now, let's get back to our quick little talk about how we actually use the steady rest, what the typical application is for that. And what we've got here is this shorter length bar, but it's a part that we still need to put a deep ID hole on and do some facing on the end.
Exactly. Part's roughly just over 20 inches long. Steady rest is still in the same position it was for the last part. Easy enough to move. It's just loosen the handle off, slide it to the desired place on the B axis, clamp it back down again, activate the steady rest,
Press the right pedal.
press the right pedal.
That's what I'm
2
bad
minutes to
at.
choose from, and you're ready to machine the front of the part, and you've got plenty of clearance for this long boring bar or whichever tools you want to put in there.
Right, you've got clearance this way, you've got clearance that way.
Exactly.
So either deep hole drilling, or maybe you're doing end work here on
It's all doing the live tool on the face. It's all, the steady rest is holding that part there, and your long tools are clear.
There you go.
Excellent.
So, as a quick wrap up, ST30 long bed is for longer shafts, and it's got the double auto doors, 60 some inches of clearance,
Correct.
60 plus inches of ability to load parts in here.
Yeah.
It's got the extended Z pocket, whatever we're calling it. So, pretty capable machine. With that said, I'd like to bring Brian back in to close us out.
So, thank you everybody for watching. I told you this would be a shorter one. We didn't lie.
It's a short one.
We delivered. We're doing a big demo day live in September. As everybody knows, there's no IMTS this year for obvious reasons. We've got a week's worth of live streams to show you the week of September 14th. We've got, what is it, John? Eight machines?
Yeah.
We've got 8 new machines to show you. We're going to have cutting demos. We're going to walk around the machines. A whole lot of things. A lot of work for us to do.
Yeah, we're working right now on it, in fact.
So please join us for that. Check your emails, check your social media. We'll be sending some information and getting you to register for that. So thanks again for watching. For Bob Singh, Andrew Harnett, John Nelson, thanks everybody, and we'll see you in September.
Thank you, guys.
Nailed it.